let's go ahead and go through what we have here. We're going to start out talking about ratios, and a ratio is a comparison of two numbers. And one of the examples that's here is three to four. If we're comparing 3 of something to 4 of something, we often write it as a fraction. I'm going to try to zoom in a little bit. Okay, so we'll often write it as a fraction, or you can just say it in English, 3 to 4, or you'll see it with a colon written in between. Because these ratios, these comparisons of two numbers, work really well with the same techniques as fractions, we're going to use them as fractions a lot. In fact, they reduce a lot like the way we would reduce fractions. So there's an example here, 28 to 7. We can reduce that because 7 goes in the top and bottom evenly, and it gives us 4 over 1. Now, here's something that's critical for you to know about ratios, and it's also critical that you know it when you go to do the homework. 4 over 1, if I do this on my calculator, if I type 28 over 7, it doesn't show me 4 over 1 because 4 over 1 reduces to just the number 4. When we're dealing just with numbers, just with a fraction, we would say 28 over 7 is just 4. But if we're doing it in a ratio where we're comparing two numbers, we have to keep the 1 on the bottom. And so that's going to seem a little odd. You just need to get used to it because a ratio is a comparison of two quantities, so we leave the 1 in the denominator. Okay? The other thing we're going to have to be able to do is clear decimals from fractions. And here's the bad news. Our calculator can't do this for us. It can help us, but it can't do all the work. So you're going to need to pick up these concepts. And let's take a look at this first example. And actually, I'll go through the key concept a little bit more. It says, if you're writing the fraction in lowest terms, so you're still going to put the first one over the second one, but then you have to look to see how many decimal places each of those numbers has. And then you're going to have to multiply by a power of 10, and that means 100, 1,000, a 1 with a bunch of zeros, in order to clear the decimals. Now, if you don't recall this, if you take a decimal number and multiply it by 10, it moves the decimal point one place to the right. So if you multiply it by 10 or 100 or 1,000, it's going to move it 1 or 2 or 3 places to the right and help you clear your decimals. So you have the option right now of just following me, just watching me do it, or trying to work through it with me. And there's more than one way that people like to think about this. So one of the first things that a lot of people like to do is, since this one has only 1 decimal place and this one has 2, we can put extra zeros on the right until they have the same number of decimal places. And then I'm going to leave some space. Many of you will like what I'm about to show as your preferred method of doing this. And that is, once you have them the same number of decimal places, you can just move the decimal place 2 places to the right, which would give us 520 on top and 738 on the bottom. I just moved it 2 to the right. And when I say I moved it, and now you might be wondering, but you didn't write it there. Remember, if the decimal point is immediately to the right of the number, we don't write it. And if you don't see one and you want one, that's where it would go. So we've now moved them both 2 places to the right. The math that allowed us to do that is, let me grab a different color, is we multiplied by not 10, because 10 would have only moved it 1 place. We multiplied the top and the bottom both by 100. We have to multiply the top and the bottom by the same. When this started out as 5.2, it might have looked like 10 would be enough, but because the bottom needed 2 places, you have to also do the same top and bottom. Okay? And now we have to reduce this fraction if possible. And this is where you would ask yourself, what divides the top and bottom evenly if we were doing this the hard way? But we have a calculator that can help us.
So that reduces to 260 over 369.
Top of the next page is example 2. And let's go through this one. This one has units, and you still just start out by, I'm going to call them GB for gigabytes. You could put the whole word there if you want. Over 7 gigabytes. And in this case, the units happen to be the same. And so we can cancel the units and keep only the numbers. If you notice it in advance, yeah, you could start right with this, but don't do that automatically because sometimes it'll be like miles and hours. There'll be two different units. You'll have to keep the units. And then we can reduce this, as we said before. I could type this into my calculator, 21 ABC7, and let me go ahead and do that. 21 ABC7 gives me 3. Recall that since we're dealing with a ratio is two numbers. So depending on the context of this problem, we might say the answer is 3, but in this case, since it's a ratio, we have to say it's 3 to 1. And then at the bottom of the page, they talk about rates and unit rates. A rate, like miles per hour, is when you're comparing two things relative, usually sometimes to time. You're comparing two quantities, and the two quantities have different units. So miles per hour, miles per gallon, whatever. There's all sorts of rates, and we'll look at a few of them here. One of the ones that comes up a lot is what we call a unit price. And you might see this if you go into Wegmans with wearing your mask, but you go into Wegmans and you look at real close at the price tags that are on the shelves. It'll often say, so if you're buying Cheerios and it's a big box, it might still say that it's 18 cents per ounce. It goes down to some unit price, so you can compare. So if there's two different size boxes, the bigger one's going to cost more, but it might be a better deal per ounce, and that's called a unit price. Unit rates and unit price are almost the same thing. It's just this is a specific type of unit rate that we deal with a lot. And let's take a look at an example here. It says it's $114 for 12 quarts of racing oil. And so we want to find the unit price. So we set up the fraction just like we said before. We keep the units, so the dollars on top and the quarts on the bottom. And then this $9.50, it came from doing the division. I'm simply going to use my division button. Let's see if I can get that mostly on the screen here. 114 divided by 12 gives me 9.5. And as money, we would put the extra zero. And that's, the units are still there. It was dollars per quart, top per bottom. So dollars per quart. Okay? Let's take a look at another example of that one. On this page, we have example 3A. So we have this woodworking company, and they produce 420 pedestals in 12 hours. So to get it started, we write the ratio, 420 pedestals over 12 hours. You can write out the whole word if you want, but don't leave the words out. The only time we leave them out is if they're identical, and then we cancel them, okay? So now we grab our calculator, and we do the top divided by the bottom. So that's 420 divided by 12. You can just trust me. I got 35. And you can either write pedestals, why I abbreviate, because your spelling is better. You can either write pedestals over hours like that, or you can write 35 pedestals per hour. You can use the word per, which is sort of the common way to say it in English. Then there's part 3B. Again, to do a unit price, we're going to take and write the basic ratio that starts out, costs for 20 bottles, so dollars, and it's 20 bottles. You can kind of see it starting out. It's going to be like dollars per bottle or cost per bottle. And I grab my calculator again. And 19 divided by 20, you can almost see it's just slightly less than $1 a bottle. Okay, I don't know if you anticipate that. If it had been $20 for 20 bottles, it would have been exactly $1. So it doesn't surprise me. I get 0.95. And so 0.95. Make sure you still put a dollar sign it's like 0.95 of a dollar. When you read this out loud, you still might read it as 95 cents, but it's like 95 cents. If you were going to write that, you'd put the cent symbol in and you wouldn't put a decimal point here. But anyways, there's our answer. Most likely, oh, and I should say per bottle. Top of the next page, they talk about proportions. Well, a proportion is when you have two ratios equal to each other. And so there's going to be four numbers. And they give an example here. 20 dogs is to 4 cats. And they're saying like 20 dogs is to 4 cats as 30 dogs is to 6 cats. And so now we're going to have a nice shortcut for our calculator to determine if a proportion is true or false. And it's called cross multiplying. Okay, and I'm going to go ahead and use example 4 right here. And so what you're going to do is on your calculator, you're going to find that product, 8 times 24, and you're saying it equals the opposite product, 13 times 15. I'm using parentheses right now to show multiplication. You could use a dot. Since there's no x's, no variables in this one, you could use the x, it wouldn't matter. Technically, I'm still in the determining portion of this. I don't know if I've determined it's true or false, so sometimes we put a question mark. We put a question mark until we know if it's true. And if you're following along, I said, again, if you just got here, I said you can make today like a spectator sport. You don't have to actually use your calculator. You don't even have to write out if you don't want to. But if you are trying to follow along, 8 times 24, otherwise you got to trust me on these calculations. Once in a while I put the calculator on screen and sometimes I don't. So this time just trust me, I got 192. And I'm wondering, does that equal 13 times 15? And that's 195. And in math, we don't say, well, it was close. There actually is times where these are actually fairly close then. If I cut a pizza into 13 and ate 8, and a different pizza into 24 and ate 15 slices, the fact that these were sort of close to each other says that they're close to being proportional. But in this course, we're not determining close or not close. It's just true or false. So this one is false. Those are not in proportion. So if you took a quiz and got 8 right out of 13, and your friend took a quiz and got 15 right out of 24, you did not do the same, you did not get the same score. Okay. Below pencil problem 4 is some of the very first discussion of pure algebra in this class. And these are some words you will need to get used to. You will hear me say them a lot. And some of you have studied some algebra before, and this is not brand new to you, but in terms of our class, it's the first we're talking about this. A variable, it's a word we use for an unknown. And we typically will use a letter of the alphabet. And hopefully you've seen this before. We actually did this last week when we said the area equals the length times width. I wrote A equals L times W. So we often will let a letter represent a number when we don't know it. The two most common are X. We use X a lot, and then N for number. But you can also sometimes just pick a variable that fits. Like here they're talking about days. I might have just chosen D for my variable days, because then if I'm solving a problem and later on it says D equals 18, it would be a reminder to me that, oh, that was 18 days. So again, this is just introducing the term. They're not showing us the algebra yet. Down here, coefficient. Coefficient is when you're multiplying a number by a variable. So in this quick example, they're showing that a pizza costs $13. And so we know that part we know. We call that well, sometimes we call it a constant because it's just a number. But if we don't know how many pizzas we're buying, we could call that X pizzas. And they're going to cost $13 each. So that would be a total of 13X. When you put the number in front of the variable, it implies that they're being multiplied. So if you see 13X, it means 13 times X. If there's a pill that I take 3 times a day, then I would know that I take it 3 times. So 3 might be my coefficient. And if I don't know how many days I'm going to take it for, I call that D for days. Then 3D would be the number of pills that I would be consuming over however many days it ends up to be. So if later on I tell you that it's 10 days, well, D is 10, then it would be 3 times 10 is 30. So sometimes we know one part of it and we don't know the other. And the part we know we call the coefficient. The part we don't know we call the variable. And they're just being multiplied together. Okay, let's see how that plays out. What we're about to talk about, this particular example, will be the beginning of a zillion problems like this that you're going to be doing. And so I want you to get this skill down because it can be a little challenging at times, especially when they throw word problems at us. So if you can get the skill, the mechanics of this skill down before we get too deep into word problems, I think you'll like it. And here's how it works. Do you see that they're giving us a proportion where they've told us 3 out of the 4 numbers. And they're going to want us to find the unknown. In this case, it's called x. And we can do that, this if you read through this, but I'm just going to spoil it and tell you what it's telling us. It says you can cross multiply. Remember, we learned on the previous page that if you have all 4 numbers, the cross products need to be equal for it to be true. So if we're going to figure out what the 4th number is, we're going to set it up so the cross products end up to be true. And so here's how this works. And I know that this example is written out, and you can go back through this later, but I want you to kind of listen through it and watch right now. And here goes. The cross product in either direction, so there's one going this way, and there's one going the opposite way. I usually like to dig out the one that has the x in it first and write that on the left. So x times 25 is 25x. And that has to equal the cross product the other direction. And it doesn't matter what order you put those 2 numbers in as long as you multiply them. And when I go to multiply them, I either want you to use a dot or parentheses, or just grab your calculator and be done with it already and just put the answer. But we don't want to use the x symbol for multiplication when there's a lot of x's, the variable floating around. We don't want to confuse them. So you'll see that I almost never use the little times unless there's no variables anywhere nearby. Okay, so now I would say 25x equals, yes. Oh, thought there was a question. And now I'm going to do 225 times 3. And that's one on your calculator I think you're comfortable with. So I'm not going to take the time to drag it back and forth each time. So here's 25x equals 675. Is everybody with me so far? The cross products of a proportion have to equal each other. And one of the directions is just numbers, so we let our calculator help us with that. Now this is the key. If you can catch on to this next step, this will unlock for you to be able to get a zillion of these questions right. There will be some word problems that will be like a little obstacle in the way, but we'll get through those. And here's the deal. They're taking x, and they are multiplying it by 25. We want to know what x is all by itself. I want this to say x equals with nothing else. So I have to get rid of the 25. Mathematically, you do that by doing the opposite. Since they're multiplying x by 25, I'm going to divide by 25. And we can show that using the fraction bar. Remember, a fraction bar implies division. But if this is an equation, whatever I do to one side, I have to do the exact same thing to the other side. And here's what we do next. I won't always switch pens for this, but 25 divided by 25 is 1. So we can just say they cancel, because if you cancel these 25s, if they divide to give you 1 times x is just x. And so x equals, and then we just let our calculator do the work over here, and that works out to be 27. Okay. You multiply the 2 that are diagonally across from each other. I usually put that on the right. You multiply the 2 that contain the x. That I usually put on the left. It's not, you don't have to do it that way, and some of the examples do it the opposite way. It's no big deal. And then you divide both sides by the coefficient of x. to truly check this, do you remember that when we did this multiplication, we got 675? Okay, it's kind of still there. We can now take our 27 and say, well, if this is truly 27, what's 27 times 25? And if I go back to my calculator, 27 times 25 also gives me 675. So I have figured out what number will make this proportion true. And I'm using algebra to help me with that. I don't want to just guess, like, oh, maybe it's 10, maybe it's 15, maybe it's 100. This is a nice procedure that gets us to our answer. How do we make it a little scarier? We go into word problems. Sometimes they're called application problems. The given ratio, it says a baseball player has 42 hits in 112 attempts. Okay, and it says her. So here she was. She went up to bat 112 times. Out of all of those, she got 42 hits. We need to make a ratio out of that first sentence, that first fact that they give us. And it's customary, because it was 42 hits in 112 attempts, to put the 42 hits up top. Please write the units. I'll tell you why in a minute, but it's super important to start out with these units. Over 112 attempts. And I ran out of room, so I just made my fraction a little bigger. It actually turns out, if you flipped this, you could still survive the problem. If you put the attempts on top and the hits on the bottom, because what's going to happen now is we're going to have similar information in the rest of the question, and we just have to make sure, since we put hits over attempts, that we do hits over attempts on this side. So let me continue to read the question. If she continues at this rate, how many attempts will it take for her to reach 105 hits? Now, without me looking closely at the words, it's possible that 105 could go top or bottom, but it's not that we get to pick. We're not choosing. We're figuring out exactly where it must go. There's already an answer set in stone where that 105 needs to go. So when I say, you're figuring it out, or I don't know what wording I'm using, I don't want to make it seem like we have a choice. We have no choice. If we put that 105 in the wrong place, we're going to get the wrong answer. But do you see that it says 105 hits? So where do we want that to go, top or bottom? It's going to be top. It's going to be, if it's hits over attempts, you line it up hits over attempts on this side. Okay? So we'll put the 105 hits. And so it's going to be hits over attempt. Now, if you had put attempts over hits on the other side, then you would switch it on this side as well. And then what some people say is, well, there's only one thing left, so I can call that X. That's actually true, but I want to give you a piece of advice. If you keep looking in the question, you can help verify that you've done this right. Because notice it says, how many attempts? That almost kind of sounds like, the unknown is attempts. This helps me feel confident, not just that I looked at the 105 and put it on top, but that my unknown, my how many, what I'm trying to find, is going on the bottom. Okay? Now, once you've done that, then we clean this up, we recopy it. Without the units. And sometimes students say, well, can I just start it there? And it's a risk, because then about half the time you get them wrong with what's going top and bottom. If you're saying, yeah, but I really did think about it, then that's a risk that you have to decide if you want to take. But the official way that I like to teach it is always show it, and then just take that extra step. It doesn't take a lot of time. And you can abbreviate a lot more than I'm abbreviating here. You could put H over AT or whatever. But does everybody see how we got here? This is the stage that if you get to this correctly, once you've practiced these, they should just flow. And I got to move this up so that it's all on screen here. But remember, the next step is I like to find the one where my variable is, which is this one. That X could end up in any of the 4 spots. It's in a different spot than it was on the last question. I like to find that product first. That gives me 42x equals, and then the product the other direction I'm just going to write it in raw form. You're certainly welcome, since you know what's coming next is to pick up a calculator, you're certainly welcome to do it that way, but I like to write it this way, especially in the notes, so that you can see I'm doing a cross product. The diagonals multiplied in one direction always equal the diagonals multiplied in the other direction. Now I clean this up for one step. 42x equals, and I'm doing 112 times 105. I'm going to say divide both sides by the coefficient of x, the number in front of x. The philosophy here is, in this previous step, x is being multiplied by 42. I want it all by itself, so I have to do the opposite of multiplying by 42, is dividing by 42. If you're multiplying and dividing something by 42, those x's cancel. Does that seem good? Now, what do I divide this side by? 42. If these started out equal, and then we do the same thing to both sides, they stay equal. But the nice part about it is, yeah, they stay equal, but now we have x all by itself here on the left, and by using our calculator, top divided by the bottom, it spits out a 280, and I'll come back to that 280 in a second. I want to make a note. I did top divided by the bottom, not because it was bigger. It's always the top divided by the bottom. The 280 is perfect, but what mistake am I on the verge of making if I move on to question 7? The units. I have to say 280 what? And there's different ways of figuring this out. If I go back and reread my problem, I'll figure it out. I was looking for attempts, right? If I go back where I wrote it originally, that also tells me that this was attempts. And so I can say this was attempts. So a strong suggestion is, after you have your answer, I want you to reread your question. And when you get to the point where it says how many attempts, I want you to visualize 280 attempts and see if it makes sense. Here goes. A hiker can travel 7 miles in 6 hours over a certain terrain, okay? If he continues traveling at this rate, how many miles will he travel in 9 hours? Based on the fact that there are 5,280 feet in 1 mile, convert your answer to feet. So, a couple things going on here. The first thing I'm going to say, for now, just ignore that whole last sentence. Let's get started without it, just dealing with miles. And here is one way, if you're completely stuck on one of these questions, if you draw like the bare bones of a fraction equals a fraction, and remember the vocabulary of today's class, one of these comparisons of two numbers we call a ratio. But both of these together, two equal ratios, so I'm going to cheat, two ratios is a proportion. So back to this one. I want to figure out my given ratio. And this one, it doesn't always come early, but in this one, many of the questions, it comes right nice and early. It says that this hiker travels 7 miles in 6 hours. Typically, we put the first one on top and the second one on the bottom. In real life, we talk about miles per hour, and so you could put hours per mile, and there's times where you would care about that as a statistic, but we're going to go with the first we put on top and the second one we put on the bottom. And then we continue reading. If he travels at this rate, how many miles will he travel in 9 hours? Do you see that they're again talking about miles and hours? And one of them they tell us as a number, and the other they say is how many. And so one of those is going to be a number, and one of those is going to be X. What one do they tell us as a number? 9 hours. 9 hours. So last time, the number they gave us, we put on top. Do we put it on top this time? No. Because it's 9 hours, you'd line it up, top and bottom, the same as the given ratio. And so 9 hours. We'll go there. Does everybody feel good about why we put it there. This is the key that makes word problems trickier than just the mechanics that we studied a few examples ago. You have to synthesize the information, and it's not always that easy. You might have to read the question a bunch of times. But let's take a look. The given ratio was 7 miles for 6 hours, and then it says how many miles. It almost sounds like X miles, doesn't it? I don't know the miles. You could have put a question mark. This is what I don't know. I don't know the miles. How many miles in 9 hours? And it's miles over hours on both sides. Are we ready to move on? Any question? Feel free to interrupt. This is the time for you to say, I don't get it. So once it's set up, we use those units to help ensure that we've set it up and gotten this far correctly. And the very next thing we do is strip all those units away so that we can focus just on the mechanics of the math. If we've done it right so far, now we do the cross multiplication. And I always like to find the one that's got the X in it, no matter where X is. I like to do that one first and put it on the left. 6 times X is 6X. That equals, then I do the multiplication the other way. That's 7 times 9. And I know some of you are saying, well, why didn't you just write that answer down on the fly? You may. If you're comfortable with 7 times 9 and you don't want to grab a calculator, or even if you do grab a calculator, you want to write it down right away, that's fine. But I like to at least show it like this in my notes as you're going through it. Does everybody see I just cross multiplied? Now the next step is, since I didn't do the 7 times 9 as we went, now I do 7 times 9, which is 63. They're multiplying X by 6. That's what 6X means. So we want to get X by itself. So we need to get rid of the coefficient. Since they're multiplying by 6, we can get rid of it by dividing by 6. Before the ink even dries, if I divide the left by 6, I got to divide the right by 6. The 6's cancel, and I get X equals top divided by the bottom, 10.5. It said, how many miles will he travel in 9 hours? So we've answered the question, how many miles? The answer is 10.5 miles.
So if we look back at our question, we've already determined how many miles this was, 10.5. But we're also asked to convert our answer to feet. We've found part A. We're looking for part B. We need to know how many feet there are in 1 mile. And as it says here, there are 5,280 feet in 1 mile. Let's return to our question.
So if I hike 1 mile, haven't I hiked 5,280 feet? Everyone agree with that? What if I hike 2 miles? What would I do with this? If I hike 2 miles, haven't I done this twice? So I've done this twice. So I could do this times 2. If I hike 5 miles, wouldn't I do this times 5? Well, how many miles did we hike? We hiked, and when I say we, it's somebody in the question, but I'm pretending I did this. Isn't this what we got to do? We got to take the number of miles times the conversion factor. I kind of wrote it backwards. I normally would write it the other direction, but if you take the number of feet in a single mile times the number of miles that you traveled, then you got to grab a calculator because this is too much for my mere mortal brain. And you can trust me on this one. Okay? And you got to put the units now, feet. So up here, so answer for part A was 10.5 miles. The answer for part B is that many feet. Okay.